So hi, my name's up there. I'm with Nulli. Just a quick forward on Nulli. We're a consulting group based in Canada, in Calgary. I'm actually based in Vancouver, but we do lots of work here in the US. We do only identity and access management implementations. So that's that. Hopefully you're here to hear about GraphQL. Yeah? Okay, cool. Before we get started though, I just figured we could try with, we could play a little game. Would you like to play a little game? It's quite easy, it's gonna be fun, you'll see. Can I have the next slide, please? Yes, it's called the identity game. How it works is I'm gonna show you some pictures, and all you have to do is raise your hand if you think that thing I'm showing you has an identity. Cool? So we're gonna start with devices from the 70s and 80s. I grew up in the 70s and 80s, and I'm gonna share with you some of the stuff that populated my universe back then. It's gonna be easy. So let's start. Everybody recognize this? HAL 9000 from 2001 Space Odyssey. Does it have an identity? Ah, okay, yeah, it does. How about R2? Yeah, okay, you guys are good. Next one, a little trickier. How about this? Does anybody recognize that? I know a couple of you are, yeah. If you're French, you probably recognize this. This is called a Minitel. What it is a little terminal that allowed you to connect to remote services. And you could do things like check your bank account, buy a train ticket, or even go on dating sites. And this was invented in 1982. So I'm pretty sure we can say the French invented the web before everybody else. But anyway. So does it have an identity? Well, actually it doesn't. It's just a dumb terminal. Oh my God, this is going way too fast for me. It doesn't, just a dumb terminal. The only identity in that scenario is the user, really. So let's fast forward, but not that fast. 2018, smart fridge. Does it have an identity? Yeah, it does have an identity. It's connected. What about that? What is that? That's the compressor that lives in the fridge. Does that have an identity? Anyone? Well, it depends. Do we need to authenticate or authorize that thing? If we do, then yeah, it has an identity. Otherwise, we don't really care, I think. What about that? What is that? That's my last one, by the way. This is a smart sensor. It's there to measure some properties of a liquid that flows in a pipe, things like temperature or pressure. And it's smart because it can upload its telemetry data to a cloud service. So does it have an identity? Yeah, you're right. So what is the point of this little game? Geez, this clicker thing, it's crazy. So the point is, we have more and more identities. As we've seen back in the 70s and 80s, the only things that had an identity were fictional characters. Nowadays, we're not even sure that our fridge compressor has an identity or not. So we have a massive increase in the number of identities we have to deal with, and that leads to some problems, like these slides. So what I'm going to talk to you today is the problem, and maybe have a look at the solution, and possibly, maybe, if we're lucky, talk about GraphQL eventually, and see how GraphQL fits in the solution, right? So what is the problem then? Oh my God. Next slide, please. This is fun. The problem. Have you? Yeah, have you guys seen these diagrams before? It shows a sharp increase in the number of IoT smart devices that are connected, and there are projections in the number of devices by 2020 that we'll have to deal with. All projections seem to agree we'll have about 50 billion devices by 2020. That is a lot of identities. That's big data. And you have to add to that, of course, all the users and all the cloud services. But that's not the only problem. So we have an explosion in the number of identities we have to deal with nowadays. But with new identities, as you could see, we have new relationships that we have to deal with, because these identities are never alone. They're always related to other things. Gosh. Let's take, for example, our smart sensor there. That sensor lives in a refinery, which maybe we'll see eventually. This is fun. And the refinery has workers, right, that are there to maintain it. And the workers in the refinery, they live in a region, and the sensor communicates with the cloud service, and the cloud service is administered by some really smart IT folks, right? And we've defined right here some relationships. And here's another way to display these relationships. We can display a graph that represents all these relationships right away. Like, for example, our device lives in a refinery. That means backward. So we'll say this is backward, this is forward. We're good? OK, so yeah, cool. So you see the workers have access to the device, and of course, the device and the cloud service can talk to each other. So representing our knowledge of the world as a graph is a really handy tool. It highlights something really important here, the relationships. Relationships in an identity relationship management system, relationships must be first-class citizens. And so that's what we can see here. But so with the number of identities that is booming, we have a boom in the number of relationships we have to tackle, and that's the second problem. The third problem that we see is APIs. We have an increase in the number of APIs we have to manage. For example, if we take just our user, well, we have an API for reading the user, another for posting. Maybe the user needs to change their password. So that's just for the user, but we have a similar set of APIs for all the other entities in our graph. Not only that, but a typical organization nowadays will have hundreds, maybe thousands of these APIs to handle. So we're witnessing nowadays a real explosion in the number of APIs we have to deal with. So the problem then, we have an identity explosion to deal with, which leads to a relationship explosion, and we have an explosion in the number of APIs we deal with. So what can we do? We need new tools. So what's the solution then? All right, well, let's have a look at possible solutions. These are our problems. We, at Nulli at least, believe that using a graph database can greatly alleviate, or if not resolve, the identity and relationship explosion problems. Representing data as a graph is a great way to simplify the problem. Not only that, but it puts relationships really as a first-class citizen. So it greatly helps. Not only that, data modeling simplification, but also, well, sorry, not too fast. But also, graph databases scale better at big scale than relational databases, in particular for queries such as friends of friends, or finding a path from a node to another, things that are really hard to do with a SQL database, especially when you consider millions, hundreds of millions of rows. For the API explosion problem, we believe that GraphQL can provide a solution, and that's the logo for GraphQL, that little thing. So at last, GraphQL, that's where we'd see it fit. Together, we believe that these are two new tools for identity relationship management. Properly used, they can solve our problems. So if we have a look at the current API explosion, wouldn't it be nice that instead we had only one REST endpoint that would work for all the entities we currently have? Not only all our current entities, but also all the future ones? Wouldn't that be nice? Well, this is what GraphQL proposes. So what is GraphQL? Well, it's a generic query language over REST. So it's an application layer query language. It was created by Facebook in 2012 and released to the public in 2015. And it's a specification, like OAuth and OIDC. That means you can read it and you can implement your own version of that if you wanted. So it's pretty much technology agnostic. What it supports is one single REST endpoint for all your queries, present or future. Isn't that cool? And of course, it could work, as I mentioned, with any database backend. Not only graph databases, but also SQL if you so wanted. But we believe it's better suited for graphs, of course. So what is GraphQL? No. Yeah, still, one more. Yes, okay, GraphQL proposes a client, a server, and a database. And so how this works is the client has a GraphQL client little engine embedded that takes user data, user input, and generates GraphQL queries. Like, for example, on the top left here, this is an example of a query which requests some user data. The GraphQL server reads the data and then calls in some backend code, for example, JavaScript or whatever else, and issues some queries against the database. For example, in this case, it's a graph database, so it's a Cypher query, Cypher being an open source language. Where are we here? No, can we stay on the same slide? Thanks. The database packages data back to the server, and the server packages the data into a GraphQL standardized response, which is sent back to the client. What you see here is a standard response from GraphQL, which returns the data that was requested. So in order to understand how this works, we have to zoom in on the server. So the server is where all the magic happens, and hopefully you'll see it will make sense. So what we need to define on the server side is a schema. And the schema is made up of three things. This is a very declarative thing. And the first thing in the schema that we need to define is types. And types are your types of entities, like your relationships, your users, your devices, or the type of objects you're willing to expose to the clients. The second thing in the schema are queries. These are your reads. What kind of data or how do you want your clients to be able to read your data? The third thing are mutators. Mutators are your rights. It's what data do you enable your users to write to, or how do you want your data to be updated? And both queries and mutators are implemented through so-called resolvers, which are actually pieces of code written in your favorite programming language, say JavaScript, and the resolvers themselves talk to the database. Hopefully that makes sense. So, too late. I wanted to give you a warning before going further. I'm going to show you some code now. Hopefully you're all good with code, nobody's allergic. All right, so let's have a look at the schema. So the schema, as I mentioned, the first thing you need to define are types, and here is an example of a definition for our relationships. By the way, these are snippets of code from our own implementation of GraphQL. We've built a full microservices-based identity server based on GraphQL and graph databases, and this is just some snippets of that. So we, of course, also have user types and device types and whatever else. So a relationship is a pretty easy object. We have the UUID of a start node, of an end node, and the relationship type between the two. Here are the queries, which is the second thing we need to define in our schema. As you can see, the schema definition itself is basically just a declaration. It's akin to interfaces in object-oriented languages. So you just specify a method name, your parameters, and the output type. So if you look at, for example, in the middle there, the shortest path A to B query, it's a query that returns the path between two given nodes, if it exists, and it returns an array of relationships because there may be several relationships to go through to go from one node to the other in our graph. So, no, the other way. Yeah, one more. Yes, mutators. Mutators are the third thing we need to define in our schema, and this is, again, an example of the mutators we are exposing to our clients. And as you've seen, it's anything that has to do with user management, like create a user, change the user's password, etc. So pretty standard, and these are all, again, just declarations. So the schema itself is not proper code. It's just a set of declarations that you can query as well from a client. So then, once we've done with the schema, we need to implement the resolvers, which are the code implementations of our schema. For example, here we have the resolver for our path A to B query. Now, the important piece in here is that middle little line there in the middle. Yes. What that does, it reads a Cypher query from file and runs the query against a database, graph database, and it returns the data. The rest is just plumbing, really. So this is the query that is read from the database. We're just matching two nodes and asking the database to give us the path between those two nodes. And this is the type of result you would get out of this query. In this simple example, this returns just two nodes. In this case, Alex owns a device. And now, as you can see, if Alex owns a device, well, maybe Alex has access to the device. You can now drive access policy decisions on this. Hopefully you see how that ties in together, right? So now here's how a client would run this query. The client would package this string, which is a GraphQL standardized query. Please go back to the, yeah, one more. One more? Yeah, no, one back, yes. This is the query, so we're providing some input parameters, the two nodes we want to find the path between, and then we're requesting some output parameters, which are the relationship parameters. Now, as I mentioned, there's only one single REST endpoint in our system, and we can send all these queries through that single REST endpoint, and through that endpoint, we can query everything in the schema. So you realize that even if we add stuff to the schema in the future, we can still use that single one REST endpoint. So this is how we would post to that REST endpoint, for example, a simple post with the query I just showed you earlier. And then this is the response we would get, standardized response. And you'd get, a device owns, a user owns a device, for example. So you would say, okay, GraphQL is a specification. It sounds like a lot of work to actually implement that. Do I have to implement a GraphQL server? Well, no, there is already a technology stack that you can use to get started right away, and that's called the Grand Stack. It provides all the tools you need. And the Grand Stack is comprised of the Neo4j graph database, the Apollo GraphQL server and client, and that's really the core of it. Apollo provided an implementation of GraphQL that is tightly integrated with these other technologies, and React.js on the client side. So together, they form the Grand Stack. So how that works, it's quite easy. You would just, you have on the client side, you have your Apollo client that runs in collaboration with React.js to generate those and understand the responses and generate the queries. On the server side, you have the Apollo GraphQL server, and of course, Neo4j has the graph database. The next one is my last slide. Hopefully we'll get to that. What's the roadmap of a typical project? Well, as always, you need to start with the business requirements, of course, and then you just have to design your graph data model, and all you need to do there is just draw it, really. That's when you're building a graph, you're just building a graph, so it's like a mind map, really. The next thing is define your GraphQL schema, and here the important point to remember is you need to specify the schema in exactly the way you expect your clients to use it. So how will your clients use it? And that's how you define your schema. And finally, you need to implement your resolvers and integrate the GraphQL client into your client, and you're done. Yeah, that's all I had, really. So now if you have any questions, feel free to ask.
Any questions?
Yes, over there.
Hi.
Hi.
We have implemented GraphQL in our product.
What, sorry?
We have implemented GraphQL in our product.
Oh, cool.
One thing we could not solve was in identity management, you see a lot of objects. They have different schemas, 200 different type of accounts. You don't know all the schema pre-hand.
Okay.
So GraphQL doesn't help when you don't know all the possible schema elements.
Actually, you can query the schema. The client can make a query to __ schema, and that you can actually query the schema. You can, what's the word again? Introspect the schema.
Yeah, but schema is not known for all the possible objects that we are going to store inside our system.
Well, you have to define the schema. You have to build yourself.
Okay.
So
that's a prerequisite, basically. Schema, knowing the schema beforehand.
Where the art is. But as I mentioned, if you think of it as how your clients will use it, so you expose the types that your clients will need, essentially. So if a client needs a user type, well, you need to expose a user type.
Cool.
Does that help? Or?
Yeah. Thanks.
Yeah, can you describe to me a little bit about how you handle authorization in a model like this?
Yeah, so the authorization is really in the resolvers. So you can define, if you did auth, you would have your scopes, and the resolver would implement the business logic of the authorization. In our case, we also use the graph. The graph itself, as I mentioned, with that little example, Alex on the device, that we drive our access policies from the graph itself, from the knowledge.
Based on the attributes and whatever the client passed in?
Yeah, or the relationships, actually, or the path, things like that.
Okay, thank you.
Yeah.
Tagging along the same aspect around authorization. So one aspect is you can do the authorization in the resolver, but you have like 5,000 microservices that are already built, and we're trying to add like a GraphQL in front of it. And each of those systems have their own authorizations built into. So now, how do you tackle that situation with GraphQL?
Well, I mean,
that's one.
Yeah. So again, I'm assuming they all use the same graph or database in the backend, maybe, or?
No, like there are 5,000 different databases,
I mean, then
different
you need
services.
as many resolvers. I mean, the resolver ties into one specific database.
Okay.
Unless you put everything in a graph, and then you can probably tie it all together in one single kind of. But there's no easy. Well, in that case, you need as many resolvers as you have databases, basically.
Yeah, pretty much. You will be duplicating like whatever the authorization you had inside.
Hopefully, you make it so that maybe you could call the same kind of middle layer, I would imagine.
And the second aspect is, again, on the same aspect of like there are 5,000 different microservices, each have their own different SLA. So since you have now only one endpoint to query all these different microservices, how do you know like which is the bottleneck, like the
again,
debug?
I mean, it sounds like something, it's not something you define again in the schema. The schema is just declarative. So in the resolver itself, you could probably do that. But that's a good question, actually. I'll think about it. Yeah.
Cool. Okay. Thanks.
Hiya. I might have been picking things up wrong, so apologies if this is a non-question. So a lot of that data that you were talking about classically in the enterprise lives in various LDAP areas.
Yeah.
Now, would you be expecting Node4j to either make calls out or to synchronize with the LDAP areas?
Oh, synchronize with LDAP? Is that what?
Is that kind of how you expect that to work?
Not necessarily, but you could. I mean, you could do that. You could implement a resolver that talks to LDAP, totally. Another way you could export, I mean, we wrote a little exporter from LDAP to Graph, actually, so you could use that as well. So I would think those would be your options.
Okay, but that's a relatively common thing, I'm assuming.
Yeah.
Okay, cool.
Hi, Alex.
Yeah.
I actually have two questions. Are there any graph database natively implementing GraphQL, or do we always need some resolver like Apollo, like you mentioned?
Yeah.
And the second one is, is there a way to do authorization on the data that we get through the GraphQL information, the response we get back? Can we filter out because the user is actually not supposed to see some information in the database, I guess?
Yeah, that ties into the earlier question from the gentleman over here. Yeah, the authorization piece, again, that would be implemented through the resolvers, the code part, and we use the graph itself for that. But you could, since it's code, you could do pretty much whatever you want. You could have the request can have a scope in it. The query itself can have a scope, and you can, filter based on that, for example, things like that. Does that help at all? But you always have to implement resolvers because, again, GraphQL is really declarative. It's a bunch of declarations. Does that answer?
Yeah, sure.
We can talk some more after as well because it looks like maybe people are coming in. I don't know.
Any more questions? I've got a final one for you. So someone mentioned attribute-based access control or attributes. So how can the graph express that authorization, and how much of a policy language do you need in addition to graph, or is graph enough?
So two ways you could do that. I mean, the nodes in the graph, the nodes themselves have attributes, so you can totally use the attributes of any given node. Another way that you could do it, depending on your actual query, you can, the attributes themselves can be nodes. So you can extract the attribute from, say, the user node and make it its own node, and then you can query that as well. So you have lots of flexibility there. But you could definitely base something, you can definitely do RBAC.
Thanks.
Yeah.
Any more questions? All right. Thank you, Alex.
Thank you.